All right, section 8.4 for Cal 2. We got to look at these trig substitutions, and these are good that, once again, this is something good to have right in front of you when you're doing this section. For integrals involving ax minus ux. Don't forget the u's are the x parts and the a's are some kind of a number constant. Let u equals a sine x. So if you have a constant squared minus an x squared, a variable squared, square root, they want you to make u equals a sine theta. Then they even tell you this converts to this. If you're looking at their triangle here. Let's see what else we want. Yeah, number 2, if you have an a square plus u square, the triangle is set up this way. And I'm going to show you what these triangles mean here when we do a problem. And this time u is a tangent theta. And this converts to a secant theta. And finally, if you have the x or the variable in front squared with a subtraction, you have a triangle that's set up this way. Once again, you have a secant theta, and this a tangent theta for when u, or they say the x is greater than a, or if the u is less than negative a, use negative a tangent theta. So this is good to have in front of you once again when you're doing these problems, because you will refer back to these. All right, let's take a look. I think we have a problem. Yes. Now, let's show what this problem is. This is dx x squared with a square minus a square, which is 3 squared, sorry. There, so a is 3, and then x squared, and then u is x in this case. And so we have a squared minus x squared. If I come back, we want to look at u equals this, and the square root of u equals this. So we want to look at those, and we said u equals x. So that's kind of important to look at those and use those when we come over. So they're showing you once again that a is 3 and x is u. So if you look at what we had in that rule that we just pulled up, it shows you that u equals a sine theta, and we said u equals x, so x equals a sine theta, and a was 3. So that's how they got x equals 3 sine theta. And don't forget, they also said this square root of 3 squared plus x squared, or u squared, equals a secant theta, which is 3 secant theta. So we want to have all these. This is Wait, that's not the one we're using, I'm sorry. This is not the one we're using. We're using this one equals 3 cosine theta, the first one, that first rule. All right. So now that we know that, we wrote those down, they're going to go to the next slide. And they're going to show that. So if you go back, we said x equals 3 sine theta. That's what we wrote previously. The derivative of x is 3 cosine theta. This is what we had written down before. And we said we already wrote down this equals 3 cosine theta. If we have x equals 3 sine theta, we can square it and we get 9 sine squared theta. That's what they got over here. All right. And if we go to the triangle, and I want to also, I mean, we haven't even really started this problem. We're just converting everything that they want us to look at. Yeah, I know it's really busy. It would look a little prettier on a board. But this is what they had. We have the a here, the u here, and the square root of a squared minus u squared. If we go back to that first rule, that first part, this is the triangle they gave us. Once again, the a is 3, the u equals the x, and then we have this 9, 3 squared, which is 9 minus x squared down here. So they're using the triangle also. Now I just wanted to show you how we're putting all this all together. So here's the original problem. And x squared changes to 9 sines. This x, we're going to change everything in the original problem pretty much. X squared changes to this. This, we already said, changes to 3 cosine theta up here. So that changes to 3 cosine theta. dx, remember we said x was 3 sine theta. But derivative of 3 sine theta is 3 cosine theta. So the dx changes to 3 cosine theta. These two cancel. Minus the du, that's still there, the d theta. So we're left with this. So all that converting that we did, all this converting here was so we can plug it straight, we can substitute it all in, trig substitution, hence the title of this. So we can plug it all in. And they give us the triangle. I mean, and if you remember in algebra, we had to create the triangle each time ourselves. In algebra, we had to do that. Here, they give us the triangle in that little formula thing that they give us. I don't know if they call that a formula or a guideline again. But this is where we're at. I mean, we're here. Which, I mean, you can change that to a negative if you bring it up to the top. And that, or they change it to even easier. 1 over sine squared is the same thing as cosecant squared. And then they're going to integrate cosecant squared. And you can look on your integration formula sheet for calculus, integrating cosecant squared. Somewhere on here, I gotta have it. There it is, equals negative cotangent. Integrating cosecant squared x is negative cotangent x. So this becomes negative, there's the negative cotangent theta. Now we're not done. This is really important now. We are not done. Because, can somebody tell me why this is not the final answer? Why we are not done? It has to do with the original problem. We need everything in X's. We need our answer in X's here. So what's next is now we're going to use the triangle. We're using this now. This is the last step. And I want to know what cotangent theta is. Can you guys, somebody type that? I like all of you using the triangle. What is cotangent theta? Type it into the chat box. What is cotangent theta? The only thing I want to know from this triangle is what is cotangent theta? Here's theta. What is cotangent theta? If anybody's there. If this mic is on. Right, this is from algebra. Does anybody remember doing this? I don't know if algebra was that long ago. Doing these things in algebra, using these triangles. Okay, so we know, well, first of all, we know tangent theta is opposite over adjacent. There goes, somebody type something in. Okay, sounds good. We know tangent is opposite over adjacent. Who did that? Let me go look at that chat box. Okay, David. Thanks, David. Cotangent theta is adjacent over opposite. So adjacent, I have to go back and see what you typed in. Is that right? You did, I think, David, I think you did tangent theta. You did opposite over adjacent. Tangent is opposite of adjacent.
Yeah, I put it in backwards.
Yeah,
I put it opposite of adjacent.
That's fine. At least you typed something in. Everybody else was asleep or wondering, I don't remember this in algebra. Or maybe not algebra, trig, but we actually did this in algebra too, and we did it in trig. So cotangent is adjacent. This is the adjacent angle. Remember, this is hypotenuse. This is opposite the theta, and this is adjacent. So it's adjacent over opposite. So this is what cotangent changes to. Cotangent theta changes to this. And that should be on the next slide.
Oh yeah, I even put it in wrong.
Yeah, that's okay.
That's why I didn't answer, because I was confused on what to put in there. So
yeah, I had to look, and you see that's what we put in. Do you see how that's what was put in? Adjacent over opposite. Cotangent is adjacent over opposite, using that you know, if you're looking at that formula at first time, why did they even draw the triangle if they wrote all that stuff in? Because sometimes you have to go back depending on what the trig function is and actually figure out what the answer is going to be. And that's it. I mean, I think they might combine put the 9 on the bottom. I think that's all they could do left. Let me go. There we go. Yeah, all they did was just bring the negative in front and put the 9 on the bottom. And the little note, cotangent theta is adjacent over opposite. That was from trig. So maybe we didn't have those triangles in algebra. Maybe we had them in the pre-calculus then. We must have had them in, you know, trig or pre-calculus. All right. And then there's some other special integration formulas. I didn't write these down, but these are theorems, so they should be in your 100 integration rule sheet somewhere. I would assume, since they're theorems. I mean, you could look for them. Yeah, they're in here somewhere. You could use your 100 integration formula, or you can print this out also, or copy and paste that, or whatever you want to do with that also. And then there's an application on this, and I'm not worried about that. I'm going to go do one of the homework problems here. You see that triangle thing, that was kind of really important to understand, that you have to go back to that triangle to get to your answer. Zoom recording. Okay, so this is a homework for 8.4. And in the first part, they're just asking you, hey, use the trig substitute, state the trig substitution that you would use for this. So I would go to the what we wrote down once again, those rules that we wrote down, and here is a square plus u square, right? A square plus u square. So once again, you have to recognize what we had from that PowerPoint, and this is a square plus u square. And if you're going to use a square plus u square, it says then your u in the actual thing says changes the tangent theta. It changes to a tangent theta. Well, a is 5 squared. And that's all it's asking you. What are you going to change your x to? It's 5 tangent theta. So you have to look at those 3 triangles that those conversions they tell you to use, and they do the same thing here. I have in this case, it's right here, u squared minus 6 squared. So remember that was the third case. And then it says u equals a secant theta, or you can say once again x equals a in this case is 6 secant theta. So those aren't too bad, because you just get them right off of those 3 triangle rules and conversions that they gave you. So the only other problem I wanted to do was 4. We're not due, we'll talk you through it maybe, because it's already been done here. And because there's one part that's a little tricky. If this is the right one, let me look. I think this is the right one. Number 4, this is the one I said. Yes, this is the one. Okay. So we're going to start with an u square minus 3 square. If you look at your rule, that was number 3. So the rule number 3, once again, where the u or the x equals a secant theta, and so x equals 3 secant theta. Unfortunately, I don't know why, but they tell you that, use this. But I mean, if you're using what they tell you to use, you should have got that already. I mean, that's where you get it. So that's what we're using, x equals secant theta. Let me actually write that down over here. X equals 3 secant theta. And on here, they give you more. It says square root of x squared minus 9 squared changes to a tangent theta, which is 3 tangent theta. Okay. So we're changing this part, the 3 tangent j theta. We're changing the x to 3 secant theta. The only thing we have to do now, if x equals 3 secant theta, we have to find dx. And the derivative of secant theta, so you have to go to your formula sheet. I mean, honestly, I don't have it memorized. I see the answer there, but I'd like to have it in front of me on my formula sheet if I had my formula. Oh, there it is, it's on the floor. And look up the derivative. I mean, I would do it if I was you, just so you get practice looking at it. Look up the derivative for secant theta. The derivative, not integration, the derivative for secant theta. And the derivative of secant theta is secant theta tangent theta with that 3 in front. So this dx changes to 3 secant theta tangent theta. So we're converting, and once again, trig substitution, the section, you're looking at that help that they did, change everything they tell you, and then once you find x, they don't tell you this, but then you have to find the derivative of x, and you just do that, and then you're substituting it all in. Look what happens. These two end up canceling, and so I have 3 tangent theta times tangent theta. I'm gonna bring the 3 out. Tangent theta times tangent theta is tangent squared theta. So I'm gonna erase this. Those canceled, and these two multiply together for tangent squared theta. And then we integrate. Oh, we don't integrate yet. They're gonna convert that. Tangent squared theta. Converts nicely to, if you look at your trig identity sheet, converts to secant squared theta minus 1. And now we're going to integrate. Integrating here. So integrating secant squared theta. See, that the reason why they converted that, because the integration of secant squared theta is a really nice one. Integration of secant squared theta just equals tangent. So the integration of this just equals tangent. And the integration of 1 then equals x, but in this case it's theta. So this is really the important. So when we integrated, we're left with this. Minus this. And this is, the next part is what really got me. It got me for a couple of minutes. But this is where we're at. Oh, let's see. So this is where we're at. And after we integrated, just like the first time, after we integrate, we go back to all those original things that we converted. Remember, everything we originally converted to, and put them back in. So we already said, or I guess we could distribute, or Yeah, no, then what they're doing is they're just putting it back in. Tangent theta, or did they? Did they tell us what tangent theta? Yeah, the tangent. Well, this is what we wrote down. We wrote down 3 tangent theta equals the square root of x squared minus 9. This is one of the things that we wrote down. And if I bring the 3 over to the other side by dividing by 3, then tangent theta equals this. See, tangent theta equals this. So this is what we had written down already, part of that rule at the beginning. Now, the hard part of this, the hard part of all this, so that wasn't a hard part. The hard part is, how did the book, or how did the homework, we know tangent theta was switched to this, but how did theta get switched to this? That's the hard part. And it took me a minute or two. I don't even think I did it here. Oh, now I wish I would have. What was one of the original things we wrote down? Oh, one of the original things we wrote down was x equals 3 secant theta. So you have to look at one of the original things you wrote down. And this is one of the original things we wrote down. What I'm going to do now, so I'm looking at the, you see, we're trying to find out what theta equals, just theta. So we're going to try to isolate this theta. First, I'm going to take the 3 to the other side by dividing. And the way to isolate the theta is then, if it's secant, we're going to take the inverse secant or arc secant. You know, I'm going to use what they use. They just, instead of negative, they use arc secant, same thing. And the arc secant and arc secant, these two parts will cancel out and we're just left with the theta. Secant and arc secant cancel each other out and we're just left with the theta. Over here, then we're just left with arc secant of 3x. Or did I didn't say 3x. I said take the 3 to the other side, sorry, and divide it. I said, when you take the 3 to the other side, you divide it. Sorry. So theta equals arc secant x over 3. And that's how they change this theta to arc secant x over 3. And it looks like that was the answer that they had. There's a lot in these substitutions. So I can't stress enough going back to that PowerPoint and having these 3 right in front of you. I mean, that last one we used is number 3. That last one we used was number 3. You see right there, the u equals a secant theta. Having these right in front of you. And then after the integration, you have to go back and convert everything to x's. So once you go back, you have to convert everything back to x's. So it's this section, I think you need a lot of paper, or you need to be neater than some of you were on the test. And I'm going to hit stop recording for now. I think